Hello all, am I audible?
Yes, Sanjay, you are audible.
I think we can start. It's 5-6. Hello all, welcome to InfraStack-Labs. So, uh, so today we will be taking Kubernetes and its benefits. So I am Sanjay Krishna. I will be the host for today's webinar. So Priyapada is my colleague and he is a DevOps engineer at InfraStack-Labs. So he will be taking the session. So Priyapada, I'm handing it to him.
Okay. Hello everyone. Good evening. My name is Priyapada Sharma. I'm a cloud engineer at InfraStack-Lab. So my today's session is Kubernetes and its benefits. Uh, let's project my screen. Is it visible, my screen?
Yes, visible.
Okay. So today's session is Kubernetes, a microservice and its benefits. Today my agenda is evolution of IT infrastructure, like how IT infrastructure developed by day, that I will explain, and benefits of Kubernetes over Docker, that I will explain, and architecture of Kubernetes, that also I will explain. After that, I will explain benefits of Kubernetes. First, we'll go to evolution of IT infrastructure. Before 2001, you can see in this picture how our IT infrastructure are there, like one physical server, one host operating system, and other services we are running over this operating system. These have so many disadvantages in this traditional deployment, because if one resource is less, we are giving it a lots of resources. They are wasting our resources. Like uh, our whole server have 8 GB memory, 8 CPU, but our work is only 2 GB memory, 2 CPU. Our whole 6 GB memory and 6 CPU are wasting here. So what developer develop one introduce one virtualization in 2001. Virtualization means a VMware we are using over this host operating system. This benefit is we are dividing our this physical server using VMware in multiple physical server. Like I have 8 CPU, 8 memory, one physical server. I use VMware over this physical server, and I divide 2 GB, 2 GB, 2 GB, 2 GB memory, 2 CPU, multiple operating system. Here I divide a physical server. So we are giving a single server to a single particular work. Like you can see it here, a single server, a single particular work. These have also demerits, like we are wasting our resources. Also, it's a slow process. Also, booting process is slow. These so many demerits here. After 2013, Docker introduced in market. It's a lightweight, and it's divide not our physical server, it divide our operating system. By this operating system, we use multiple operating system, like Linux we can use, Windows we can use, uh, any number of operating system we can use over a single physical servers. It have no boundary limit. Also, it have one benefit is it is not tightly coupled. Others are tightly coupled with each other, because it means if this resources use 2 CPU to memory, this is used 2 CPU to memory, this is used 2 CPU to memory. If its work is over, if it stop, it release that 2 CPU to memory again to this physical server. Then other person can use their resources. So it have so many benefits. Then if we are using this container, then we need someone to handle those containers, because containers are volatile in nature, because it means it will delete automatically, it will terminate automatically. So Kubernetes introduced here. Kubernetes is a open source. It control our Docker. It means it orchestrate our Docker. It handle our Docker servers, and if one Docker container terminate or delete, it create one more Docker container over that Docker container, or where one container was create, where one container will delete. That Kubernetes will handle all these things here. You can see this picture, and this Kubernetes handle all these Docker containers. So this this part end in Kubernetes, and Kubernetes we are using in such a way like using microservices. If we are using microservices, in that point we are using Kubernetes. Microservices means uh, mainly you can see you are using some shopping applications, like Flipkart, Amazon, or any shopping application. Uh, Previously, our application is coming on a single part, like all things, our shopping page, our product, our cards, our billings, our profile in a single application. It bundle with single applications. If anything down, like my billing process is down, then my total application will down. We can't use total application for a single thing, single point down. We can't use total applications. This is a monolithic architecture. Before Docker, before Kubernetes, we are using this type of architecture. After that, we are use microservices. It means we we divide our a single applications into multiple parts, like one product part, one card, billing, profile. We divide our application in multiple parts. If anything stop, if my billing is stopped, people shall communicate with my product. We will check my product, go to their cards, go to their profile. When my billing is up, people are buying their things. So this is the advantage of microservices. Now I will go to architecture of Kubernetes. In this architecture, you can see one master, two worker. It means one master can handle two worker at a time, or if we connect three worker, it can handle three workers. So you can see here API server. In those are architecture components: API server, controller manager, scheduler. These three things are present in master node. And kubelet, uh, kube proxy are stands in worker nodes. API server, what it will do, it will uh, communicate all these things. It is a one thing communicate all these things, or with developer. Those developer want to develop anything in this Kubernetes server. The developer will communicate by API server. Controller manager controls like where my one container start, where my one container delete, where my one container run in which place there are space is there, that place it will start one container. Controller manager handles this thing. Scheduler handles when, just imagine I have four container, just one container suddenly terminate, but we need four container. Scheduler suddenly start one container over the container where it will delete. Kubelet, we can go worker nodes. kubelet connect my worker and master communication, kubelet. And kubeproxy gives IP to my pod, to my container or pods, and communicate through browser, kubeproxy. Now architecture is over. Now I will explain the benefits. Kubernetes have so many benefits, but I explain a little number of benefits like auto scaling, auto healing, deployment and services, rolling updates. It auto scaling means my one application is running. Suddenly, uh, traffic are increasing. It will scale up my containers. That is auto scaling. Auto healing means I have 4 containers are running. Suddenly, one container delete. Again, that scheduler what will do? Start one container. It maintains 4 number every time. Auto healing. Rolling update means when my application is running, I develop one new version and try to update that application. At that time, through zero downtime, we deploy our applications. That is rolling update. I'll show you these 4 things in lab. This is my my server. You can see.
Priyapada, can you
Yeah,
show how Docker containers are running, how before even jumping into the features,
yeah, yeah. I'm
which is
showing Docker containers.
the controller, which are the worker nodes. Now, how do you see the
No,
cluster status?
currently I am using Minikube.
Okay,
So Minikube, because it's chargeable, that high level architecture. So I am using Minikube. Inside Minikube, both master and worker are present inside Minikube.
okay.
I'll show you. This is my Minikube. Inside here, controller and master and worker both are present inside this thing. This is a small architecture. We can run Kubernetes through 3 things: Kube ADM, Minikube, and Kubelet. So I am using here Minikube.
So,
So
what
I
is
can,
the difference between these three deployment
in
tools?
3 things, Cube ADM and Kubelet, we are using a high level architecture like where we're using one master, 3 worker, or 4 worker, that high level. And Minikube we are using for testing purpose, like inside one server we are using master and worker, both things.
Okay.
Yeah. Now I'll show you how to you auto scaling things. This is my auto scaling. This is my one YAML file. Here I mention my pod name and one label, and this is my image, and this is the main part of my auto scaling. Here I mention how many CPU I require, how many how many CPU I claim, how many CPU I require. Here you can see one pod, it's creating. It's running now. My one pod is running. This is the auto scaling command I am using. Like we can use YAML file. Also, we can use a declarative command for auto scaling. Here, what I use, this is my deployment, and this is my pod name. This name, my deployment, and when my CPU is 20% increase, my CPU percent, then increase server minimum once one pod will there, maximum 10 pod it will increase. You can see here one unknown, it will collect my metrics, just collecting now. Now it's collect my metrics 0 by 20. My target is 20. If my CPU reaches 20%, then it increase one more pod. Here you can see one by one pod is running, one is ready. Now I'm going inside this pod. I'm trying to trying to running something in pod. Now you can see I'm inside this pod. This is my deployment. This is my pod. So I'm running, I'm updating this thing. Here I'm performing some updating things. You can see here in this screen, uh, pods will be increased. Takes time. You can see here pods are created. 3 is creating, others are pending. 3 pods are created because it have limited space. It have 2 CPU. Uh, uh, it have limited space, so it will create a limited pod. You can see how many pods create here. 6 pods are created. You can see 1 pod is pending because due to less resources, so that is pending in pending state. Also, I have also add one dashboard here. You can see 1 pod failed due to why it failed. You can check here insufficient CPU because CPU is all CPU are uses. So insufficient CPU, so 1 pod is failed.
So in this case, do you have any information on how do you do a capacity planning for running number of replicas, how many pods you
Yeah,
can run?
we we have one calculator.
Okay.
Here is a calculator. It shows Kubernetes. It shows like if I say uh, T2 medium, it have 4G memory, 2 CPU. This is pod requirement. This is pod limit. Here we set how many memory we require. What is our limit? In this condition, we can run 17 pods like 128 GB memory, 100 milli CPU. Also requirement 128 memory. Sorry, also limit 100 milli CPU. We can run 17 pods at a time in a server.
Here, if you see this uh, current image, right, you can see memory is
Yeah,
underutilized.
yeah.
CPUs, uh,
You
yeah,
can adjust this thing.
yeah,
You can adjust if we adjust it. You can see memory also increasing.
right.
CPU also decreasing because once so it is a limit. Like if memory is using this much, then CPU utilization is this much. So if we increase CPU, that that will decrease our or sorry, if we increase memory, that will decrease our CPU limit. Because if we increase CPU limit, it will decrease our pod count. You can see I adjust 97% memory use to 95% CPU I will use. Here I can create 15 pods in 4 GB memory, 2 CPU instance.
Okay.
Yeah. It will take time to decrease this thing because also now memory is in sorry CPU is in it's using. Can check. Here you can see my memory utilization and CPU utilization of pods. It will take time to decrease. You can see here memory and CPU graphs here. Also, if I'll show you here one thing, but auto healing, I will show you here. Here, 5 pods are running. If I delete one pod here, I deleted one pod. Here, one pod is in pending state. Now, see the time. It is 15 seconds. Now this pod is running because that time one pod was pending. Here, this is one pod is pending. So if you check here, it's running now. Which one? HW2J5. HW2J5. It's running now.
Because one was deleted, it got the resource.
One was
right?
deleted, so it's running now. So memory and CPU, it's underutilized, so it's running on again. But again, one pod was in pending state. The decrease time is taking takes some time. You can see here terminating started. No, this is the termination. Okay, I will show my deployment and service. It's taking time. Here, here is my one YAML file. Here I mentioned deployment. In Kubernetes, so many objects are there, like those I mentioned here, pods, deployment, services, and auto scaling, healing. Those are some objects or horizontal auto scaling. Those are objects in Kubernetes. So deployment also one object in Kubernetes. Here my object is kind is deployment, and I am using rolling update. My role is rolling update. I'm using a node application here. Here my 4 replica. I'll create 4 replica of my node application. This is my my application.
So where are these
This is
hub
yeah.
images?
I'm sorry.
Okay.
Yeah. This is my Docker. This is my Docker hub. I created a Docker image and push it my Docker hub. This is my one node application, and this is I create one new version of this image and I give it name v1. My new version of node application. This is my two node application. So first I will run my old node application. This is my node application, Priyapada slash node docker. You can see here, Priyapada slash node docker. This docker image, I'm pulling it here. This is my application name, node container. Here I am using 3000 ports. It's ideal time second means in it's 5 seconds per each pod, ideal time. If one pod is not connecting to 5 seconds, it terminate and again new pod will create. Here is the important thing of rolling update. It means minimum 50% of my pod will update. Minimum 50% pod will be there during my update because my traffic is there. So 50% will be there and 50% will update. This is my strategy. We can change according to our traffic, according to our uses. Here I created one service. This is my service name. This is my application name. This is my role. This my service type is load balancer. But we can't see it here because this load balancer is not connected. I will show you by IP. Here my node port is 311, 341. You can see all ports are terminated. Only one port is there. See here, previously four ports are there, but now one port is there. Due to my CPU utilization is less, so ports are deleted and running one port. Here you can see my deploy rolling update. One pod deployment is created. This is 0 by 4 already. You can see how many pod will ready. 4x4 is ready. 4 pod is ready. And see deployment rolling update. 4 pod is ready. So also I created one service. We can check that service is created or not. Yes, one service is created. Rolling update. Now I can here you can see 4 pod is created. Is running 4 pod. Your pods 4 running. One replica is running. You can see it here. If I delete one pod, here one creating. You can see the time. It's running now. One is terminating, one is running. So 1, 2, 3, 4. Always 4 pod will be there. This is auto healing plus. Okay, I created that. This is my IP. By this IP, I will connect my application. I can't connect it from browser due to that node load balancer. I will show you in terminal. You can see here this thing is building in my application. My version 1 application. I write this thing. I will show you. This is my version 2. So I return it. Hello from paper J2. This is good evening. I will show you this thing in version 2. When I will update my application, I will show you. That was my previous version application. If I keep /will, you can see some changes. Hello world. Here we got this thing. Here we got hello world. If again I will change to ready. Yes. Here we got great. It's works. Means my application is running. Now I am updating my application. You can see here some changes will be happen when I will update. Here my application name is Priya/node repo/node docker v1. I'll use that application here. Now I am applying that application, applying that new version. Uh, keep watching this screen. You can see some changes. Some pods are terminated, some pods are creating, some are running. We'll see after create this thing. You can see it here also. This is my old version. Those are terminating. This is my new version. Those are running now. It's terminating my old versions. Those are created 7 minutes ago. Here you can see, though this is running, this is created 11 seconds ago. This is running, this is created 11 seconds ago. This is running, this is also created 11 seconds ago. It means my new pods are created, new application is created, my older application was deleted. So you can check them in my dashboard also. This is replica 2. You can see it here. This is my older application. This is my newer application. Older application is 0 by 0, means all are deleted. My new application created 4 by 4. 4 replica created. You can also check it terminal. You can see it here. 4 replica first create, then 2 are from 4 to 2 running, then scale down. 4 are there, 2 scale down, then scale up again 4, then scale down 1, then scale down 0. Means all are scaled down. My older applications are scaled down. My newer applications are running. These are the summary. Uh, Event. This is an event. For the for running. Okay, you can check my newer things created or not. This is shows like Hello Priyapada V2. This is my newer application. If I give you can see good evening. I give it ready. You can see thanks to connect me. My newer application is ready now. See all our one CPU are using all parts. So memory are using according to their uses. Two deployments. We perform two deployments here. First is older one, second is newer one. And last is monitoring and login. You can monitor this thing from this dashboard, like how many pods are created, how many pods are running, how many replicas are there, how many containers are there. You can see, check it here. This dashboard. Also, you can check all namespace. You can see 5 deployments, 5 pods, uh, 14 pods means it are all are from Minikube. Okay, okay. This thing only. This session. Thank you.
Thank you, Priyapada. Does anyone have any questions? Hello, guys.
Hi, Priyapada.
Yeah,
I have a question. Suppose
yeah.
I have a stack built
Okay.
with the monolithic architecture. So, at what point will it make sense for me to migrate to microservices?
I'm not getting I'm not getting your question.
Suppose I have an existing stack, okay?
Okay, okay,
It is based off of that monolithic architecture.
okay,
At what point will it make sense to migrate to microservices?
okay. At what point? If your traffic is so high and it's
Hmm.
fluctuating continuously, we have no control of your traffic. At that point, you can monolithic to microservices.
Yes.
Yeah, at that point, you can change your application from monolithic to microservices because you have no control of your traffic. You don't know when your traffic is increasing, at what point it is increasing. At that time, you can change.
Okay, so you mentioned that example of shopping sites, right, which have a large
Yes,
number
shopping
of
sites. Yeah,
updates
because
coming in every.
if you check in sales time, like big billion day or Black Friday sales, at that
Right.
time, their traffics are so high they
Mm.
can't control this weak traffic because their have their sales are from in 1 week, I think. So they have no control. So that they are using this microservices. Also, you can see our so many microservices are there: Netflix, Amazon Prime, Amazon website, and Hotstar. If you see 2020 in World Cup, I think, no, not World Cup. 2020, some Hotstar app shows their blogs how they change their how they change to microservices. Also, some lakhs of people, some crores of people are
Hmm.
joined Hotstar, but that time Hotstar is running smoothly.
Okay. So it is better capable of handling
Yeah,
more traffic, of
yeah,
volatile traffic.
handling more traffic.
Okay. So what about deployments?
I shows na like
Yeah,
deployment
yeah.
have zero downtime.
I understood. Yeah. So this zero downtime, how is it achieved? How is it being achieved?
Okay, I'll show you here.
So that part is not too clear about it.
I'll show you. Here I mention my strategy. Here, my screen visible.
Yes, yes.
Yeah, this is in this strategy. I mention it's a rolling update type. My rolling upgrade maximum surge is 50%. Means 50%. How many pods? I have 4 pods here, 4
Okay.
replica. Maximum 50% means 2 replica. Two
Those.
replica will update maximum. Then maximum 50 replica will be there to handle my traffic. Means
So you'll have two up
50%
and
to
running
yeah,
to
two
handle what
running, two
is coming
hand
in,
to the terminate. Yeah,
to being worked upon. Okay.
yeah,
Yeah. Thanks, Peter. Got it.
yeah. Also, we can change it according to our uses. You can use 25%, 10%, like one. It's one is new created, one is terminate. We can change it according to our traffic.
Okay. Thank you. That's clear.
Okay, thank you, Susan. Does anyone have any questions?
Yes, Sanjay.
Yeah.
Priyapada,
Yeah.
let's say like I already have an application running in my Kubernetes. So
Okay.
could you tell me like how we could monitor that particular application? Yeah.
Yeah. In this dashboard, we can monitor this
Okay.
dashboard.
Is there any other options rather than this
Yeah,
dashboard?
we can connect our Grafana to our Kubernetes. Grafana through
Okay.
Grafana we can monitor. It has so many
Okay.
plugins. I will show
So
you.
how is the data being like sent to Grafana like using Prometheus only, right?
Yeah, using Prometheus.
Okay. Okay. Thank you.
Yeah, okay. These are the Grafana Kubernetes dashboard. Yeah, you can see here. They are Grafana is providing this dashboard in default dashboard.
Okay, Priyapada.
This one.
Thank you.
Yeah.
Okay. Is any other having questions? Hello, guys. I think that's it. I think every question is cleared. Thank you, Priyapada, for taking
Yeah,
this
thank
wonderful session. And thanks everyone for joining this webinar. Thank you all.
you. Thank you. Yeah.
So,
Okay. Roshan, how is my webinar? Sanjay, how is my webinar?